Hey guys, in this video we're going to talk about solving linear systems by graphing. Now note that there are multiple methods to solve linear systems, but in this video we're specifically talking about graphing. Let's look at our first example. In this example we have two equations and we're going to go ahead and solve this system by graphing. So let's look at the first equation. 2x plus y is equal to 1. Now you can graph this using a table of values if you wish. I'm going to convert this equation to slope-intercept form and then graph because in my mind it seems to be the quickest way, but whatever way works for you is fine. So when I convert this equation to slope-intercept form, I have y is equal to negative 2x plus 1, and our negative 2 is our slope. So you can represent this as negative 2 over 1, or 2 over negative 1 in terms of if you're going to rise or fall or go left or right. And our b, or our y-intercept, is 1. So when we graph this, and what you don't want to forget is to label your axes. Now, our y-intercept, or the point at which the graph crosses the y-axis, is 1. So let's go ahead and plot that. And now we're going to use our slope as a map to tell us how to get to the next point. So our next point would be I can fall twice and go to the right once, and that's what I'm going to do. So if I fall twice and go to the right once, I end up here. Or I can rise twice and go to the left once, and I'll end up there. You can use a ruler to connect your points. I'm going to go ahead and freehand this as best as I possibly can. But remember, all graphs should be done with a ruler and pencil. Okay, so that is the line of the equation 2x plus y is equal to 1. Now, let's take a look at the next equation. You can write that into slope-intercept form as well. Okay. And that will be y is equal to negative x. Now, this equation, y is equal to negative x, pretty much when you look at this, the negative 1, or the negative, is almost like negative 1, or it is negative 1. That is our slope. And your b is going to be 0. It's almost like saying plus 0. Okay, that is your b. So in other words, the graph crosses the y-axis at 0, 0. And in order to do my slope, or use the map that the slope gives us, I can fall once and go to the right once, or I can rise one and go to the left once. I'm going to choose to fall once and go to the right one. And so I can connect my dots. And in this case, like I said, I'm going to freehand it, but you should probably use a ruler. And that is the graph x plus y is equal to 0. Now, in terms of figuring out what the solution of the system is, the solution would be the point at which these graphs intersect. In other words, the point, and that point would be here, and I'm going to use a different color. This is the point. 1 comma negative 1. It's a point that lies on both of these lines. And so this would be the solution, or the ordered pair, that would prove both of these equations to be true. And the way you can figure that out, or see if it actually works, is by substituting these values for x and y into both of these equations and seeing if it rings true. So let's do that and see where we end up. Okay. So when we substitute, we end up with 2. X is 1 plus y is negative 1. Is that equal to 1? That's the question. Well, 2 minus 1 is equal to 1, so that is true. And in the second equation, x is 1 plus y, which is negative 1, is that equal to 0? Well, 1 minus 1 is 0, so that is true. So therefore, the ordered pair 1 comma negative 1 is a solution to our system of equations. And we did that, or we got that answer by graphing. Let's look at one final example. In our final example, we have a system of linear equations, and we're going to go ahead and solve by graphing. Like I said before, you can use a table of values to figure out how to graph both of these, but I'm going to go ahead and simply use slope-intercept form for this process. So the first equation, negative y plus 3 is equal to negative x. We're going to convert that to slope-intercept form. Now, if I missed you in the first example in terms of the steps, because I did not include the steps, let's go ahead and include them in this example. Negative y plus 3 is equal to negative x. So I'm solving for y, so minus 3 on both sides, and I'll be left with negative y is equal to negative x minus 3. Now, negative 3 and x, they are not like terms, so you cannot combine them. And then I can divide by negative 1 on both sides, and that will leave me with y is equal to x plus 3. Okay, and that's the graph that I'm going to go ahead and plot at this time. So in this case, our slope is 1, and our y-intercept is 3. This is our B, and this is our M. All right, so the graph crosses the y-axis at 3, and our slope, I can go up 1, right 1, or I can go down 1, left 1, and that's what I've chosen to do. I'm going to use a freehand, but use your ruler for accuracy purposes. And that is the graph of negative y plus 3 is equal to negative x. Now let's go ahead and graph the second equation. Now notice the second equation is already in slope-intercept form. Y equals mx plus b, where in this case your b is 0, okay? Your b is 0. So the graph will cross at 0, and the slope is negative 1/2. So I can go up 1 over twice, over to the left twice specifically. Or I can go down once and to the right twice. That works as well. You'll still accomplish your goal. And I'm going to connect my little dots. Okay. And that is the graph of the equation y is equal to negative 1/2 x. Now, in terms of the solution to this system, you're looking for an ordered pair that lies on both of the lines. Well, that happens to be the point at which these two graphs intersect. And this point is negative 2, comma 1. Okay? So the question now is negative 2, comma 1 actually the solution? Now, graphing it, it definitely shows you it is the solution. But if you're not sure, go ahead and check. And the way you're going to check it is simply by substituting the ordered pair back into the original two equations. Okay? So let's go ahead and do that. Let's get rid of this stuff. Now, negative, our y is 1 plus 3. Is that equal to negative x? Well, negative 1 plus 3, is that equal to 2? Well, negative 1 plus 3 is 2, and 2 is equal to 2. So that's a solution to the first equation. Okay, the ordered pair is a solution to the first equation. So let's look at the second equation. Our y is 1, and that's equal to negative 1/2 of x, which is negative 2. Okay, so is 1 equal to the right-hand side? Well, negative and negative is a positive, so we don't have to worry about that. And then 1/2 of 2 is 1. So, yep, it is a solution. So this is how you would solve a linear system by graphing, and you will also know now how to check to see if your solution is true.